The BMW is driving back just off the recovery because it has serious issues. Let's see what it's all about. Today's challenge is to fix this BMW 330e. It's a plug-in hybrid on a G20 platform. Now, where it gets interesting is that this car comes from far away, comes actually from Liverpool, and we are in London, so quite a long way. And it came on recovery because it cannot be driven. It has quite a lot of error codes on the dash, 12-volt battery system not charging, and it is also being checked. However, there are some conflicting information. One of them, he said it might be a problem on the gearbox. The other one said it might be the high voltage battery. Both of them quite expensive to be fixed, but you have to make sure we pinpoint the right part to replace or to recondition or whatever, because otherwise the process is going to get very expensive. Let's see how we're going to get this BMW back on the road, because now it has many lights on and it cannot really be driven. So I just brought it in from the recovery. Let's get in the workshop. Hello from OGS Mechanics. I'm George, and here we fix cars, all type of cars, electric, hybrid, combustion engine cars. Have a look around and follow me for interesting repairs translated in videos. We have run the initial diagnostics, and we do have some error codes in the SME and IME. Now, this was the diagnostic, was in between the high voltage battery and the electric motor. We have insulation fault, so this is the way to start. We'll disconnect the 12 voltage, we'll disconnect the service connector, disconnect the cables, and do an installation test. And then we'll decide which component we're going to strip. So let's get on with it. What do you suspect?
Most probably
in the battery. So the data in the battery, what do we have in here? We do have we do have the error codes related with the installation, but we saw, and also crash message. It's very interesting why we have crash message. We erased this and it came back. Because the car did not have a crash, but it's not permanent. However, our installation fault is permanent. And in the live data, this is the problem. The resistance is way below. So something is leaking badly. It's interesting that it still goes in ready mode from time to time. Yeah, but it's a massive leak. Let's get on. We have now access to the high voltage battery, and the plan is to try to isolate the isolation fault. And to do so, we disconnect the high voltage cable that runs into the battery. This cable brings charge to the battery and also takes it out. So there's only a high voltage cable. Now, the suspicion is that there's either an isolation problem within the battery or outside the battery. We have to conclude where it is before we start stripping components. With the ignition turned off, we should haven't anything out of the battery, so it's impossible for us to check the battery whether it's an isolation fault. To do so, we need to remove the full battery. However, before we do so, we can check the other components, and we're gonna do an isolation test straight into the high voltage plug. If we're gonna reveal anything, we're gonna start tracing that circuit. If we cannot find anything here, probably the next call will be to take off the battery and do an isolation test within the battery. Let's see what we get. To understand the high voltage system, it's a circuit separate from the 12 volt circuit of the car, and then they should not interfere. That's what we cause a current leak. So with this test, we should read infinite, or at least over 15 mega ohms if the resistance is fine. A low resistance, it means a current leak. It means an interference between the circuits, the high voltage to the low voltage. And let me show you how it works. So basically I'm touching those connectors, and this is obviously complete circuit. So we do not expect to have something like that into the high voltage connector. There we go. Can you see that? This is a massive problem. There's a massive leak, so it goes straight to zero. So something is leaking quite badly. And although at this stage we cannot pinpoint 100% that the battery is fine, but because we have here such a massive current leak, the next call is to trace the cable and then complete the resistance check on the next point, which is going to be the EME under the bonnet. The EME is the inverter that powers up the electric motor. So let's find some components. So the components under the car, here is the gearbox. And right at the front of the gearbox is the electric motor, which is powered up by this cable that comes from the EME, Electronic Machine Electronics, which is a control unit at the top that acts as an inverter and converter. Here is the charging unit. So from the plug-in port, current comes here and then to the module on the top and then back to the battery. So through that cable, current travels both ways. So the next call is to drop the car down and do an isolation test in the Electronic Machine Electronics module. The next step is to do an isolation test here. So this is the cable that comes straight from the high voltage battery into the EME control unit. And we have this disconnected. And what we want to know, whether we have an issue here, whether the cable is the problem, or forward from the unit going forward, and this is the connection to the electric motor inside the gearbox. So let's resume our testings. So we have nothing on the cable. Infinite resistance. So there's no problem here. We eliminate it. Now, of course, if it's not here, we expected that the problem is going to carry on from here, which it does. Now, at this point, the next step is to remove the connector that goes to the electric motor and do an isolation test on the connector. So we eliminate this control unit and go further down the line. Now, what we have to establish whether the current leak is from here down or within this unit. And again, back to our tool. To do the test when it's down to ground, that's what it is. So we're going to test. Okay, so this side, it seems to be fine. What are we interesting to see? A low resistance close to zero. Let's see what happens when we go to connector. Bam, straight to zero on all of them. So we are narrowing it down. It looks like the problem comes from the electric motor. Next step, car up in the air and get to the connector straight to the electric motor. We're going to disconnect and we're going to do same check. We have to conclude whether the problem is the cable or actually comes from the electric motor. Car up in the air again. So here is our next step. We're going to remove this connector, and again, an installation test on the connector itself and inside the motor. We have to see where the resistance is going to be very low. Let's go, Lal. We are narrow it down. Let's go, Lal. Okay, so is it the cable or is it the electric motor? We are going to find out. Back on the tool, we need to find an earth, a ground, same test. Here, the cable looks good. This is going to take us to the electric motor. Let's see if that's the case. Oh, that's what it is. And here, there's a current leak. So again, we should read no resistance. However, on all those ports, there is resistance. So it means drop the transmission because something is not right in the electric motor. It kind of sounds like BMW was right when they said it's the gearbox. Now the challenge is to see how we can fix this, because the price tag that is being quoted, it was very high, about £15,000. We have to keep it as low as possible. We like to work with green parts, with recycled parts. So let's see if we can do or what exactly can be done, because a new transmission is going to be thousands of pounds, way too much comparing to the car value. So next stage, drop the gearbox. The nice prop shaft with a special tool, exhaust, yeah, shield. Let's get on. We have now full access to the stator with the rotor moved, and now we see exactly the extent of the damage. So it looks like one of the coils on the stator literally blew up, literally caught fire. And this is our current leak. So when we look at it, we should not have this such a low resistance, and the reason we have that is that on the other side of it, this coil is kind of shorting onto the body, and then obviously that's how the current leaks from the high voltage system into the low voltage system. So it is a leak, it's not a short circuit, it is a leak because there are two circuits: high voltage, which runs on those cars about 350 volts, and then obviously into the 12-volt circuit into the body of the car. So the solution is another motor. Problem is BMW, they don't sell separate disassembly. The stator is literally pressed into the body of the gearbox. So there are special tools needed to extract that. Even to take the rotor out was not easy. Therefore, the solution is another transmission. However, we can use a second-hand, a used transmission, but it's not going to be straightforward. But this section, the motor, is not a programmable part, so we can use this section. However, the electronic, which comes on the bottom in the sump, which is called the Mechatronic, it has to be swapped over from this car, from original gearbox to the new one, because it has data related to the immobilizer. So if we straight swap a second-hand gearbox, it's not gonna start. And now we have a gearbox. We have ordered. It is a gearbox from a breaker's yard. And how we start, first of all, is do an installation test, make sure we are not having same problem as the other one. What we need to access, it's the connector. So we're going to put the gearbox on the side. We're going to run our installation test, and if everything is good, we will start dismantling both of them to rebuild this one over here. Lal, I need help, please. We need to put it on the side. Here, as in here we have, which side we're going to put it on. Okay, let's put it on this side. Let's take this mounting off. We have positioned the gearbox on the side so we can access the connector to the motor. This is the connector from the other gearbox, and that's the way it goes. It powers up the electric motor inside, and we should have infinite resistance between this and the body of the gearbox. We're going to set up our equipment, and then let's test the individual. And this looks very good. So we are on the track. This electric motor is actually in good condition. And before we move forward, we need to swap over the Mechatronic unit from the original gearbox into our donor one. So we will remove now the sumps on both of them, swap over the hydraulic unit, and then we should be ready to put the gearbox back on the car. Let's get on. This has no more oil. The oil sump on those gearboxes has the oil filter attached to it. So whenever do an oil change, if you want to replace the filter, the sump pan has to come together. Now, this is our Mechatronic unit, which has the electric plate on the back of it, and we have to transfer it from here to the other gearbox. Mechatronic is off from the new gearbox. We will do same exercise on the old gearbox, and then we'll put it back here. So looking that the oil looks quite clean in this gearbox. So this is, I'm just looking at it. This is an indication that the gearbox should be in good condition. Very important. The oil condition, it could say a lot of the gearbox condition. So in this case, it looks like we've got a good gearbox from a wear point of view, and also the motor we know is fine. Let's get on to the other one. Connected here. Now the sump goes on. The gearbox should be soon ready to go on the car. I'm fine here. Tip top. With the sump on, I think we've done for the day. So Let's put it in position. Tomorrow we're going to swap them over and then we'll plant it onto the car. Let's call it a day. And this morning, back to action. Hopefully today is the day that this BMW is gonna run on its own. Let's see. The gearbox is now ready to go on the car. Oh, let's bring this other one in. Right. Should we turn around, guys? Okay, so how are we gonna put it on? I should bring it a bit more to put a jack. Yeah. Maximum. First step is to put a gearbox on the gearbox jack because this is very heavy to lift it by hand. So this jack is going to help us to plant the gearbox back on the car. Let's get on, guys. No, the motor is very heavy. Center. Yeah, but it's a big surface. Big surface to spread it. Are you ready? Whew. Let's go. Okay, come on. Lift it up. Lift the jack up. Gearbox is now attached to the engine. It is the time where we connect all the wiring on top, and then we're gonna secure the gearbox to the chassis, prop shaft, high voltage, and soon we're gonna be ready to go. The regas process is ready now, so we have pretty much everything that is needed to fire up this BMW. So the next step is going to be to connect the 12-volt batteries and the high voltage service connector, and then time to test. Is this BMW going to work, Lal?
Yeah, it will work.
Do we feel lucky?
Yes.
Is it gonna be more drama?
It will work.
So it'll work. I like the vibe. It has to work. Let's see. Okay, I'll connect one, you connect another one. Can you bring a tent to secure them? Is to connect the high voltage service connector. So far no error codes, but we don't have yet the ready one. Let's see what the diagnostic tool is going to say. Ooh. We still have the isolation fault in the SME. Now we have to see, is this going to erase? So we're gonna erase all the error codes and then we're gonna rescan. In the SME we had isolation fault, which is obviously normal for the problem that we had. But sometimes it could be the case that an error can be triggered in there and cannot be erased. So we're not excluding at this stage. We might still have a bit of drama in the SME, but let's see. Still error codes in SME. Yeah, so the problem is that he has triggered a fault. Let's see if the ready will come on. So this error code is being stored, and it might be one of those error codes that it cannot be erased. And we'll know if the ready comes on, we know it's fine, but I don't think with that error code there. Still high voltage system error by charging, but we have the error code into the SME that it won't clear. We know it's not charging and we still have errors in SME, but we want to see if we have electric drive because there's still a bit of battery left. And we do have electric drive. We have electric drive. We have charging to the 12 volt system. The only problem, we have some errors in the SME that were triggered by the isolation fault that we had before. But in reality now there's no error codes because the isolation value is fine. But we have to see how we're gonna get rid of those error codes. But we have drive. We made progress, but still a bit of drama left. The test plan for the error, it takes us to a step where the SME is going to do isolation test, and the isolation resistance, it is okay. And following the test plan, this should erase the error codes, and it says they've been successfully done. And if that's the case, we need to allow the vehicle to go to sleep, and then when the vehicle comes out of sleep, we should hopefully have the charging working and be able to erase the fault in SME. So hopefully we are getting close to. So we have the electric mode enabled, we have the 12 volt charging system operating. We still had those error codes that were preventing us from charging the high voltage battery. And what else was not working? The charging.
The driving also okay.
The driving was fine. The driving was fine. It was going on electric mode. So, and out of those error codes, those are our error codes. So we're gonna do once again, delete them. So we have 2, 5, 6, 5 error codes. We also have to switch off the ignition. Let's see if we manage to erase any of those. And then we're gonna turn the ignition off, allow the vehicle to go in sleep mode. And this procedure, it could not haven't been done with the Autel. It doesn't have, this is a bit of a special function that you don't find. Autel is an amazing tool for diagnostic. It has a bit of coding programming, but when it comes to more in-depth function, it doesn't have this. And what we're using now is using the original BMW software, ISTA P. Let's see. We actually have more error codes than we had at the beginning. However, according to the test plan, we're gonna switch the car off, leave it to enter sleep mode, where the screen is already gone blank. And then let's do an error code reset. And let's see, what do we have here? Okay, so we are left with 4 error codes. Gonna try one more time. So we managed to erase one error code. There's still test plan for others because we have error codes still in the SME and the charger control unit, but we managed to clear one of them in the SME. So let's see if this has made any difference. Red, an error, blue is fine. Initially we managed to get it to blue, but only for a little bit.
Fault detected.
Fault detected, yeah? Okay, so still not right. We have to carry on with our testing. It's not as straightforward as I would like to be. But yeah, the thing is, here is the issue. The car is working fine, but when he had the issue, he stored those information, and they cannot be just clear as normal error codes. So it is a test plan, and as we just did one, the control unit does the measurements, and if the measurement is fine, then he reset the error code. So we still have to follow the other test plans. So where we are at the moment, we are left with 4 error codes, 2 in the charger control unit and 2 in SME. Now it's a very strange thing because the one in SME said can only be erased after 4 hours of having the high voltage system actives. And because we now have voltage, so the battery charge is good, and we also charge the voltage at the battery. So the voltage is 14.8 measured on both batteries. The next step is we're gonna install the exhaust. We're gonna check the gearbox oil level. We're gonna check the car is drivable, and we'll see how we're gonna get the high voltage system active for 4 hours. Probably it'll be driving 4 hours. It's a bit interesting, the test plan, and only afterwards we'll conclude whether is anything else to be done also on the charger unit, because in there we also have error codes. But since the charging is working fine for the 12-volt battery, we're good to go on a road test.
Yes.
Yeah. So this is going to do, and then we'll see afterwards
After the test.
how it drives. Let's do that. We have pretty much all the components together, and we need a 4 hours continuous drive on a high voltage system. So probably it'll be quite difficult to have a continuous drive. But first of all, we're gonna go out in the road test because now the car can be driven. We have charge on a low voltage system, so we're absolutely fine to drive it. We're probably not gonna have 4 hours in one journey, but let's have it out to see also how the transmission operates, very important, and how the car feels, because we never drove this car. Electric mode operates, and also the high voltage battery has been charged, as we had a bit the engine running. So we had 4 miles range, now we have 6. So that also works, but the electric mode also works fine. Good progress for the day. So we had the BM running for 4 hours. Basically, we left it in the car park. We select extra boost mode. So the engine was running for over 4 hours, and now is the time to check if we managed to clear all the errors in SME as per the test plan. If we manage to clear, that means we have made progress, but I want to see what else is left. So let's do a quick erase, because we actually don't even have them anymore. SME fault free. That's good. Let's rescan, because it was also another error in the charger, and want to see if the charger works now or if, okay. So those errors are still here. The errors in the charger control unit are still present, and according to the test plan, the charger is defective, the charger control unit. And we also have in EME isolation. We're gonna run another test, but we know according to the test plan for the charger control unit, we need to replace that. We have another unit, it might work. We want to confirm the part number. Let's do one more test after clearing all the error in SME. So can you switch the ignition off? Let's see if the charger works. But I'm not holding big hopes, because we still have errors in the charger control unit. So okay, let's see if it's gonna stay like that for long, because if there's an error, it could turn to red. Yeah, well, that's the case. Kind of expected, because we should not have any error in the charger control units. And according to that test plan, we are now going to replace the charger and then resume the testing from there. So it's like comprehensive, because it's not just one thing, and then obviously have to take them step by step. But we made progress. We have no more errors in SME isolation fault. There's still an isolation fault in EME, but again, step by step. We replace the charger control unit, and then we're gonna resume from there testing. Let's get on. We do have a replacement part, and hopefully today is gonna be the day that the BMW finally is going to be fully functional. Let's see, Lal. Is going to be the day today? Yes. Let's hope. And while we are at it, we are here, we also we ordered the earth cable for the rear diff. That is very interesting, is discharging the electricity produced during functioning into the rear diff. Is a very interesting, because there's absolutely nothing electric on the rear transmission. However, it seems that while it operates, electricity starts building in it. So it's a quite important aspect. Charger is now installed. It is the time that we're gonna lower the car once again, scan it. We have to get the module coded to the car, but we're gonna scan it to see error first. We're gonna try to see if we have any charge without it being coded, but obviously we'll have to get it coded. So let's get on. Drop it down. Let's scan it for any errors. We still have error code related with coding, which is absolutely normal, because the control unit is from another car. However, before we do the coding, we want to see whether it is any change, whether it does charge without the coding. So it does trigger an error eventually. We will do the coding and then test afterwards. It was just an exercise to see whether the charger will allow coding, will allow charging without coding. It seems that it doesn't. We still have some isolation fault which they were not there before, so kind of suspecting it's all because the coding on the charger. So we'll do the coding on the charger, and then afterwards we're gonna get to the plug charger. Let's go. Currently 5 errors we have to deal with, but out of them main one is the no coding into the charger interface, and obviously is normal because the control unit comes from a different car. Afterwards, hopefully we should manage to clear everything and we should get the BMW up and running as it should. This is the next step. Now we are in process of programming the control unit that we just replaced. However, the way that this tool works is going to do a complete vehicle update. So this is going to be quite lengthy. Fingers crossed all the procedure is going to go through fine, because the way it is, if any control unit fails during programming, the programming stops. So that's a bit of a downside on the BMW tool. Every time when you have to code a program, one particular control unit, the software does a complete update to the whole of the car. Let's see. So we're going to execute the measuring plan, and we expected that once we calculate the measuring plan, we're going to have a time scale of how long everything is going to take, but we expect it might take even a couple of hours or so. So let's see, because there are quite a lot of updates. Programming and complete vehicle update, it has been completed, but not without a bit of drama, because during the procedure the software froze for some reason, and then we were left with a blue screen on the audio system, which was quite a bit frightening, because it could have been that the unit has gone down. We managed to recover it. We've got a KLE coded to the car. We got a complete software update. We have no more error codes in the charger. However, we kind of bit back to the square one, where we have installation fault. I cannot believe that we still have an isolation fault. So we have no more error codes into the charger. No codes. Coding has been completed successfully. There's still an isolation issue. It's gone from bad to worse. I mean, we don't know exactly where we're standing. We replaced the gearbox. We replaced the charger. We thought we fixed everything, but we still have an isolation fault. Now we're going to strip back to the EME, and then we're going to restart the isolation test to see what else is it doing. We hope it's not going to be the new gearbox. Well, new, it's a used one, but it was fine when we tested off, and it was we didn't have any error codes, but there's still something more to it, so more checks to be done. Hopefully we're going to get this BMW done soon. Now we've got new parts. So new charger, well, it's not a new, it's a used one. Hopefully today we're going to fix the BMW, and it's going to be out on its own with no errors. But before we're going to go and fit it, let's do an isolation check. We don't take it for granted that it's good, and it's actually not. Can you hold it so we see? So what we expect not to see is something like that. That's the current leak. So anything towards this side, it looks okay, and we're gonna check all those 4 connectors. So let's see. Good, good, perfect. Spot on. It looks like we finally have a good one. We have to put it on. Of course, we have to code it afterwards. Procedure should be simple because the car is up to date, so we're only gonna have to code this. Fingers crossed we are on track to have the BMW done today. Yes. Let's go. Believe it or not, we have so far four units, used one, and none of them were good, and the last result was to get a new one. direct from BMW, and this is not cheap. So this is around 1200 plus watts, something like that. But it was our last resort. 4 units we have. Some of them they had current link, some of them then had no communication whatsoever. It looks like there's something very common with them, so I think we're going to strip one of them to see exactly whether there's anything that can be repaired. But for now, we really need this BMW out, so we're going to move on with the new part, and hopefully that will be it, and there's nothing more out after this. Do you need a 10 mil? Yeah. We're going to take it off shortly, install the new one, and obviously coding part before it will operate as it should. So wiring while LAL is connecting the high voltage connectors and the cooling pipe, and then we'll drop it down to do the programming. Here is the time that a programming of the new control, the charger control unit, is being done. This is the old unit. We had obviously coding that had to be done before the unit operates correctly. So we have no more errors related to the charger. Actually, nothing related with the high voltage system. So we are on the right track. And now what's important, let's see if the charger works now, finally works, because this is the last thing that it was to be done. We need to turn the ignition off before we try. Quite a lot of components had to be replaced on BMW, but hopefully we are to the last one, and we're looking for blue, not red. Ooh, let's see. Blue. The wheels have clicked. We like this color. Finally, we get to blue. Finally, let's wait for 30 seconds because we had it. Now we also run the check. If anything else is not right, this is going to change to red. So, but we have not seen anything else. I'm not suspecting that we're going to have anything after so many parts that we replace. And you know what I have not filmed is the fact that we've tried to use a second-hand charger. It didn't work because we bought a few and all of them faulty. Four. We had 4 control units and they all faulty. Be quite curious to probably strip one to see exactly what goes wrong on them. I haven't done one yet, but we should do that. Anyway, the new one worked fine. Programming went through, and finally blue. Now the stage, the next step actually will be to have a road test, but then we have to have a full charge and the range test. This is very, very important, but I'm pleased. Amazing progress for today. We'll leave it a bit on charge and then we'll be out in the road test. We had the car overnight on charge and we do have a full charge on it. Early on it was green. It was, yeah, still charged a little bit, but it is full, and now is the time for the road test. So it should be the first time with a fully charged high voltage battery, and we want to see the range that we managed to get out of it to assess the condition, the state of health, and obviously we're hoping no more errors will occur. So we can disconnect now because we did had it overnight. Everything seems to be good. We checked up the coolant level, all good. Let's see. Currently, what we are told is a range should be 22 miles. Low fuel level, still 70 miles left. If everything goes fine, we should get over 20 miles. Maybe close to around 25. We'll see. A similar model, we managed to get over 30 miles. But yeah, it's all depends. Again, we're gonna leave everything off. No air conditioning. We'll try to drive as eco as possible. Gentle acceleration. We also set the mileage counter to 0. let's see exactly what we're gonna get out of it. We'll move to the hold on and the menu of the diagnostic. We're gonna move to the battery stats, because in here what is also important to see how the battery is performing during this drive test. Starts looking good. This is one very important um, figure that we're looking. This ideally has to stay as close to zero as possible, ideally below 20 millivolts, and this is the difference between cells. Sometimes can vary with the battery age and so on, but ideally for maximum range this figure has to be as low as possible. We have now done about 10 miles. We still show about 13. What we've done now differently, we choose the speed on 70, where before we've done it with 65. And what I find here on the battery, I find a bit of imbalance between cells. Now this car, it has been stood for a while. Vehicles, batteries that they stay for a while, this is not very good. And what we try to bring it back to life, to a working cycle. We're gonna do a full cycle of having it down, and we want to charge it probably once more, and then gradually we believe it should improve the balance in the battery, so it should have constant lower difference. But at the moment it is, like I said, probably first time in quite a few months since this battery was fully charged and is having a working cycle. So not too concerned at the moment. Okay, so we've done so far 23 miles and it still shows 2 miles. The driving style was completely different. We are driving a bit higher speed. We had to use a bit of wipers. We had to use the wipers because it's raining actually now in London, where we are a bit outside London. So let's see. Okay, 26 miles. It shows 0. So probably shortly the combustion engine is gonna kick in, but still 26 miles, and the condition were different the last time. I'm pretty sure we could have done a lot more. So all 26 miles we've done on electric drive, 26.9, but good enough, because the book says about 25, 30, something like that. So the battery is also good condition. Probably, like I said, few more charging and using cycles, and then if everything stays fine, expecting the difference on the cells to come down. And this is more the difference, the imbalance comes a bit more during the use, not when it's stationary, where actually it is load on the battery. Yeah, so we're gonna do a few more cycles before we'll conclude the car is gonna be ready to go to its owner. But yeah, good progress so far. So we've done quite comprehensive road tests. We've charged and used the battery. Everything looks okay. High voltage system, all good. So we are finally ready to hand over the car to its owner. Remember, this car came from Liverpool and we are in London. And the car has been off the road for a few months. And I was just talking with a customer the other day, and he was so happy that the car is finally ready, because he kind of lost hope. Yeah, I mean, he was trying for quite a bit to have it fixed, and it was unsuccessful. Sometimes because of inconsistent diagnostics, sometimes because an expensive repair quote. So what was wrong? The transmission, electric motor, it was faulty. Now this motor does not come separate, as from BMW they're gonna sell only the full gearbox. We managed to get hands of a used one, and then build from 2, we built 1. Then we fixed the initial problem. We then had problem with the charger control unit, which is this module. We tried to use a second-hand one, and out of 4 modules, none of them were right. So in the end, we had to buy a new one. Now, with the car being fixed, there's another interesting question. Let's get to the board. What was the cost of the repair? And we had the gearbox, we had the charger, the main components, and then obviously with relevant work. So how much did everything cost it? Well, let's start just to have a figure in mind. So the new gearboxes, we looked up online on BMW website, and it looks like it's around 12,000 plus VAT. So a new gearbox. So this is one of the estimates that the customer was given, and obviously at this price tag only for the part, he was quite reluctant to see how the bottom line is going to look. However, we did not have to go through that options. We have found a used gearbox, and when we tested, it was looking quite good. And the box that we have found, it was costing 1,700 plus VAT. So I think in here we had a significant save. Then we've obviously built from 2. We made the gearbox. We've transferred the Mechatronic control unit. Then obviously remove an installation. For that charge replacement and the gearbox, we've charged £1,350 plus VAT. Charger, it was quite a big saga with the charger because we tried several, none of them, they were in good condition, and in the end we have to settle for a new one. A new charger, 1,233. This was a new part from BMW. Cost and replacement of the charger, not such a big job. We kind of rounded with diagnostics, replacement, and also programming, which we've done it with the BMW tool. By doing so, we also update the whole vehicle to the latest version of software, and this has costed 900. We rounded. So if we are to think about it, adding all those amounts, they're probably going to come to 3, 4, 5, just over 5,000. Plus we're going to have coolant, oil, some other bits and pieces that we haven't accounted for yet. But I think it's just around, let's say, 5,000, I think 100 or 200 plus VAT. So if we compare this with what would have been only the gearbox, what it was initially estimated by BMW, I think we have delivered a significant reduction. We're happy because the transmission we put the hands on, it looks quite good. We've checked it. We have new charger, and we're really happy with the way the BMW runs. So it was a comprehensive repair, but we've done it because this is what we do here in the workshop. So if you like our video from the workshop, this is what we do, interesting repairs, and we want to translating them in interesting videos. So if you like them, don't forget to subscribe to our channel, give a thumb up for the job, click the notification button, because often we have interesting repairs translated in interesting video. I will see you next time.